Welcome to the deep dive. I want you to just take a moment and think about the cosmos. Its sheer vastness. I mean, for centuries we've looked up, trying to figure out our place in it all.
And that understanding, it's changed, hasn't it? Dramatically, often at a huge cost, personally and intellectually.
Exactly. And today, we're diving deep into one of the key figures behind those shifts. Galileo Galilei. People call him the father of modern science, and we really want to get into why.
Yeah, well, look at his revolutionary ideas, what he actually saw with his telescope, and that huge clash he had with the establishment.
It's a story that tells us so much, I think, about just asking questions and thinking critically, even today.
Definitely. And for this, we're leaning heavily on Galileo's own words. His big works, dialogue concerning the two chief world systems, and also Sidereus Nuncius, the starry messenger.
Plus some context from biographies, analyses like planetary motion, and even the biographics channel.
Right. Good range of sources.
So, okay, before Galileo starts pointing his telescope upwards, what was the picture? What did, everyone believe for ages?
Well, for, over 1,000 years, the standard model was geocentric. Earth in the middle, not moving. Everything else, sun, planets, stars going around us in these perfect circles, these spheres.
And that came mainly from Ptolemy and Aristotle.
Primarily, yeah. Aristotle especially provided the sort of philosophical underpinning. He had reasons, things that seemed like common sense back then.
Like what?
Like, well, if the Earth was spinning really fast, wouldn't there be a constant massive wind? Or if you threw a ball straight up, wouldn't it land, way behind you?
Okay. Since that doesn't happen.
Exactly. Conclusion. Earth must be still. Simple. Logical from their perspective.
And this wasn't just a science thing, was it? It got tangled up with everything else.
Oh, absolutely. It wasn't just accepted science. It became woven into the fabric of society, even into Christian theology. It felt like questioning, well, everything, the whole order of the universe.
So where did Galileo get this itch to test things, to look for evidence? Did that start early? Maybe at home?
It seems like it might have. His father, Vincenzo Galilei, he wasn't just a musician, a lutenist, he was a music theorist, and he actually did experiments.
Really? Like what?
He apparently showed how the pitch of a string changes with the square root of the tension. That's proper physics, establishing non-linear relationships through experiment. So yeah, maybe that empirical spirit ran in the family.
And didn't that show up early on? There's that famous story, the Leaning Tower of Pisa one.
Ah, yes, the classic. The story goes, and is often attributed to his student Viviani, that Galileo went up the Tower of Pisa.
Or maybe Delft, some say.
Oh, maybe Delft. Yeah, the details are a bit fuzzy. But the core is he drops two objects, different weights, a heavy one and a lighter one.
And boom, they hit the ground together.
Supposedly, yes. Directly contradicting Aristotle, who said heavier things fall faster. It's a great story.
And even if the specifics are debated, it perfectly captures his approach, right? Challenging ancient authority with actual observation. Apparently, some professors back then still refused to believe it, even seeing it.
Which tells you a lot. That resistance to evidence, even when it's right there. That was a fight Galileo faced his whole life. It really foreshadowed the bigger conflicts to come.
Especially when he got his hands on a telescope. Now, he didn't invent it.
No, it was a Dutch invention, a spyglass. But Galileo heard about it and just massively improved it, made it way more powerful, up to, 30 times magnification?
Which was huge back then. And he wasted no time pointing it upwards and writing about it. That was Sidereus Nuncius, the starry messenger.
Yep, published fast, in March 1610. And what he reported in there, it just started blowing the old model apart, piece by piece.
Starting with the moon. What did he see? It wasn't a perfect crystal sphere, was it?
Not even close. He looked in November 1609, and instead of some smooth, perfect orb, he saw, a world. Rough, uneven. He described huge prominences, deep valleys, and chasms. Mountains and craters, basically.
And he figured out the shadows, how the light changed as the moon waxed and waned, were because of these mountains.
Exactly. Just like mountains cast shadows on Earth at sunrise or sunset, it made the moon seem, Earth-like, imperfect, physical.
Which was a fundamental blow to the whole Aristotelian idea of perfect, unchanging heavens, a huge crack in the foundation.
A massive one. And it just kept coming.
Next up, Jupiter, January 1610. What happened there?
He noticed these tiny little points of light near Jupiter. At first, maybe just stars, but he kept watching night after night, and they moved.
Moved how?
They were orbiting Jupiter. He realized they weren't stars, they were moons. 4 of them. He called them the Medicean stars, trying to get some patronage.
Moons orbiting another planet, not Earth.
Precisely. And according to Aristotle and Ptolemy, everything was supposed to orbit Earth. This just didn't fit at all.
I bet that caused some uproar.
Oh, immense controversy. A lot of astronomers just refused to believe it. Some said it was like a trick of the lens, an artifact in the telescope.
Until others confirmed it.
Yeah, eventually Christopher Clavius, a respected astronomer, confirmed the observations. But think about it, a mini solar system centered on Jupiter. It directly contradicted the Earth-centered model.
And it wasn't just theoretical. You mentioned a practical use.
Yes. Galileo worked out their orbits incredibly accurately. So accurately, in fact, that observing the timing of these moons eclipsing Jupiter could be used as a kind of celestial clock.
To figure out longitude.
Exactly, which was a huge problem for navigation and map-making back then. His method was actually used for land surveys, like remapping parts of France. Amazing, isn't it? From spotting dots around Jupiter to fixing maps on Earth.
Truly incredible.
Okay,
what else did the telescope reveal that chipped away at the old system?
another really big one, Venus. Starting around September 1610, he observed Venus over time and saw it showed a full set of phases, just like our moon. Crescent, half, gibbous, full.
Why was that so important?
Because the prevailing Ptolemaic model just couldn't explain it properly. Depending on where you put Venus's orbit relative to the sun in that model, you'd only get certain phases, like maybe crescents, but not the full set, especially not a full Venus phase.
The Copernican model, with Venus orbiting the sun inside Earth's orbit.
That predicted it perfectly. As Venus goes around the sun, we'd see all those phases from Earth. This observation didn't prove Copernicus was right, necessarily, but it pretty definitively proved Ptolemy was wrong.
So it forced people to reconsider. Maybe not jump straight to Copernicus, but...
Right. It led many astronomers towards other models, like Tycho Brahe's system, which was sort of a hybrid planets orbit the sun, but the sun orbits a stationary Earth. That could explain Venus's phases without requiring the Earth to move, which avoided other problems like the lack of observed stellar parallax.
the parallax problem. We'll come back to that. Did the telescope show anything else relevant?
2 more quick things. 1, it just revealed so many more stars than anyone had thought existed. The Milky Way wasn't a cloud, it was countless individual stars. The universe suddenly seemed vastly larger.
And the stars themselves.
He measured their apparent sizes and found they looked much smaller through the telescope than previous estimates, like Tycho Brahe's had suggested. This helped counter an argument against Copernicus.
Which argument was that?
Well, the argument was, if the Earth moves around the sun, distant stars should show parallax, a slight shift in position. Since nobody could see this shift, either the stars were incredibly far away or the Earth wasn't moving.
And if they were that far away?
Then, based on the old size estimates, they'd have to be absurdly, unimaginably huge. Galileo showing they appeared smaller made the incredibly far away option seem a bit less absurd.
Okay, so armed with all this observational evidence, the imperfect moon, Jupiter's moons, Venus's phases, the scale of the universe, Galileo decides to put it all together.
Right. Into his major work, the dialogue concerning the 2 chief world systems, finally published in 1632. And it wasn't just a dry textbook. He framed it as a conversation.
A compelling narrative, our sources call it. How did he structure it?
It's presented as a discussion over 4 days between 3 characters. You've got Simplicio, who's the traditionalist, the staunch defender of Aristotle and Ptolemy, the old guard.
Okay, Simplicio represents the past. Who else?
Then there's Salviati. He's the sharp, open-minded one who argues for the Copernican view, using Galileo's observations and reasoning. He's pretty much Galileo's voice in the book.
And the third?
Sagredo. He's presented as an intelligent, curious layman. He asks questions, pushes back on assumptions from both sides, but generally leans towards Salviati's evidence-based arguments. He's sort of the audience's stand-in, learning along the way.
Clever. It makes complex ideas more accessible.
Yeah.
So how did Salviati and Sagredo go about challenging the old Ptolemaic system in this dialogue?
They really picked it apart. They pointed out how incredibly complicated the Ptolemaic system had become, with all its epicycles and different cycles, riding on cycles, just to make the planet's observed movements fit.
Compared to Copernicus.
Compared to the Copernican model, which explained things like retrograde motion planets appearing to move backwards much more simply and coherently, just as a natural consequence of Earth and other planets orbiting the sun at different speeds.
And they tackled that common sense argument about Earth's motion, the one about not feeling the wind or being left behind.
Absolutely. Salviati introduces Galileo's crucial idea of relative motion. He argues that everything on Earth, us, the air, the ball you throw up, shares the Earth's motion. So relative to the Earth, things seem stationary.
He used an analogy for that, didn't he?
The ship.
Yes, the famous ship thought experiment. If you're inside a ship moving smoothly without rocking, you can't tell it's moving just by, say, dropping something or watching a fly buzz around. Things behave normally relative to the ship.
That's a fundamental shift in thinking about motion itself, undermining Aristotle's physics. Hugely. It lays the groundwork for inertia. Salviati also challenges Aristotle's idea of natural motion, that things just want to go to their natural place, like rocks falling down. Instead, he introduces Galileo's concepts, closer to inertia and momentum. An object in motion stays in motion unless something acts on it. It's moving towards quantifiable laws, away from these qualitative, sort of purpose-driven explanations.
So faced with all this, the telescope evidence, the arguments about simplicity and relative motion, what were Simplicio's main counter-arguments? How did he defend the old ways?
Well, the big one was still the lack of observed stellar parallax. If Earth is moving, the stars should appear to shift slightly over the year. Nobody could detect it.
Which, as we know now, is because they're just incredibly far away.
Right, but they didn't have the tools to measure it then. So for Simplicio, no parallax meant no Earth motion. Plus, he constantly falls back on the sheer weight of authority. Aristotle, Ptolemy, centuries of accepted wisdom, tradition.
And Salviati's response, with Sagredo chipping in.
They just kept hammering away with logic, observation, and evidence. They'd say, okay, we can't see parallax yet, but look at Venus. Look at Jupiter's moons. How does your model explain that simply? It was a constant push for empirical reasoning over just trusting the ancients or philosophical arguments.
This wasn't just an academic debate in a book, though. Championing Copernicus had real-world consequences for Galileo, serious ones.
Extremely serious. His views, especially challenging the Earth's fixed position, ran headlong into opposition, especially from parts of the Catholic Church and conservative astronomers. They saw it as contradicting certain interpretations of Scripture.
What was the spark that really ignited the fire?
Things started heating up around 1615. Some of his writings, like a letter explaining how Scripture and science could coexist, were sent to the Roman Inquisition. The authorities got nervous. This sounded a bit too much like reinterpreting the Bible, which was seen as dangerously Protestant territory.
So the Church stepped in officially.
Yes. In February 1616, Galileo was formally warned. He was ordered by Cardinal Bellarmine to basically stop teaching or defending the idea that the sun is the center and the earth moves. His arguments in Rome, however logical, didn't sway them.
But then, years later, he published the dialogue. What happened with Pope Urban VIII? I thought they were on good terms initially.
They were. Urban VIII had actually been a supporter of Galileo, but when the dialogue came out in 1632, the Pope became absolutely furious.
Why?
He somehow became convinced that the character Simplicio, the kind of slow-witted, stubborn Aristotelian, was meant to be a caricature of him, a direct insult.
Oh, wow. That couldn't have helped.
It was disastrous. It alienated the Pope and also the Jesuits, who had been pretty important allies for Galileo. Suddenly, his protectors were gone or even turned against him.
And the hammer came down, the trumpet.
By August 1632, orders went out to seize all copies of the dialogue. The printer was told to stop. In September, Galileo himself was summoned to Rome to face the Inquisition.
What was the trial itself like? It lasted months, right?
February to June 1633. Initially, Galileo tried to argue he hadn't really defended Copernicanism after the 1616 warning, that the book was just presenting arguments, but under pressure, possibly including the threat of torture.
They actually threatened him with torture.
The records suggest the threat was employed. He was an old man by then. Eventually, he was persuaded to admit that, well, maybe a reader could get the impression he was defending Copernicus, even if that wasn't his true intention. But he still denied actually holding those views after 1616.
But it wasn't enough. The verdict.
June 1633, found vehemently suspect of heresy. He was forced to publicly recant, to abjure his errors, sentenced to prison.
Which was commuted.
Yes, commuted to house arrest. But he spent the rest of his life confined to his villa near Florence. And the dialogue, his masterpiece, was placed on the index of forbidden books.
A crushing end to his public career. But did he stop working?
Remarkably, no. Even under house arrest, he kept thinking, kept writing. That's when he wrote another incredibly important work, Two New Sciences, published in Holland in 1638. It dealt mostly with mechanics, kinematics, the strength of materials, foundational work for physics.
And he wasn't totally isolated.
He still had visitors, people who brought him news and scientific texts from Northern Europe. And thankfully, his assistant, Viviani, preserved his library and papers, so the work continued, even in confinement.
Despite everything, his legacy is just immense. You mentioned Einstein and Hawking calling him the father of modern science. Why that specific title? What did Einstein point to?
Einstein really admired Galileo's relentless fight against dogma based on authority. He said Galileo accepted only experience and careful reflection as criteria of truth. That's the key, isn't it?
Combining experiments with math.
Exactly. Showing the laws of nature could be expressed mathematically. And crucially, being willing to change his mind based on observation, not sticking to ancient philosophy if the evidence pointed elsewhere. That rigorous empirical approach, deriving theories from the real world, that's what kickstarted the scientific revolution.
And part of that foundation is something called Galilean invariance or Galilean relativity. Can you break that down simply?
Sure, it's a fundamental idea. The basic laws of physics work the same for everyone, whether you're standing still or moving at a constant speed in a straight line.
Like in the ship experiment.
Precisely. Your speed doesn't change how gravity works or how objects collide as long as it's constant. This principle became the bedrock for Newton's laws of motion. And amazingly, it was also a central starting point for Einstein when he developed his theory of special relativity.
Incredible. A 17th century insight paving the way for 20th century physics.
Yeah. I mean, Einstein expanded on it, of course, dealing with light speed and so on.
Yeah.
But for everyday speeds, Galileo's principle, embedded in Newton's laws, works perfectly.
So, looking back at Galileo's whole life, his struggles, his discoveries, what's the lasting message? What does his story symbolize?
I think it really symbolizes the sheer power of questioning things, of challenging the status quo. It shows that progress, real leaps in understanding, often demands that we confront deeply held beliefs, especially when new evidence comes along.
It's about being willing to look at the evidence and adjust your view, even if it's uncomfortable or goes against tradition.
Exactly. His story is a powerful illustration of that intellectual courage. True understanding comes from inquiry, not just inheritance.
So Galileo Galilei, incredible courage, pushing for a new model of the cosmos against immense pressure, pioneering the use of evidence, and truly changing how we even do science. He fundamentally shifted our view of the universe and our place in it.
Absolutely. And his story never really gets old, does it? That tension between established beliefs and new evidence is always with us. It makes you wonder, doesn't it? What are the chief world systems being debated today? Where is critical thinking most needed now to sort through the noise and find the evidence? Something to think about.